Hello and welcome back to Chopstick Maths. In this video, we shall solve a problem from the chapter Exact Differential Equations, exercise 1, sum number 6. The given differential equation is dy by dx is y upon 2y log y plus y minus x. Now, if you look at this differential equation, it is not in the form m dx plus n dy is equal to 0. So we'll have to first get it in this form m dx plus n dy is equal to 0. So let us cross multiply this. This will become 2y log y plus y minus x dy equals to y dx. Now let us rearrange this. Y dx minus 2y log y plus y minus x dy is equal to 0. Now we will take the negative sign inside. So it becomes y dx plus the sign inside the bracket changes. Every term changes the sign. So this would be minus 2y log y minus y plus x dy equals to 0. Now this particular equation can be compared to m dx plus n dy is equal to 0. And on comparison, we get m is equal to y and n is equal to minus 2y log y minus y plus x. Now we need to prove this differential equation is exact. And we can prove this if we can show that the partial derivative of m with respect to y is equal to partial derivative of n with respect to x. So let us start taking the partial derivative of m with respect to y. So m is equal to y. So del m by del y is del by del y of y, which is 1. So del m by del y is equal to 1. Now n is minus 2y log y minus y plus x. So taking the partial derivative of n with respect to x, del n by del x is minus 2 del by del x y log y minus del by del x of y plus del by del x of x. So since we are taking the partial derivative of n with respect to x, we have to treat y as a constant. So y log y is treated as a constant, hence the del by del x of y log y equals to 0. So this would be minus 2 into 0. Again, there is a y here which is to be treated as a constant. So del by del x of y will be 0. So this would be minus 0. And del by del x of x is 1. So this is 1 here. So del n by del x is equal to 1. So del m by del y is equal to 1, which we call it as 1. Del n by del x is equal to 1, which we call it as 2. So from 1 and 2, we can say that del m by del y is equal to del n by del x. So we can conclude that the given differential equation is an exact differential equation. Now the solution for this differential equation is integral of m dx keeping y as a constant plus integral of n dy integrating only those terms in n which are free of x is equal to c. Now let us proceed to find the solution of the differential equation. Now the given differential equation is y dx plus minus y log y minus y plus x dy is equal to 0. So integrating m with respect to x, but we have to treat y as a constant. So y would be outside the integral sign. So this would be y integral dx plus. Now integrating m with respect to y, but integrating only those terms in n which are free of x. So this would be, the first term is minus 2y log y. This is a term which is free of x. So we can integrate this. So it will be plus integral minus 2y log y dy. The second term is minus y, which is also a term which is free of x. So we can integrate this. So this is minus integral of y dy, and the third term is an x. This term contains an x, so we neglect this term. So therefore, y integral dx plus integral minus 2y log y dy minus integral y dy is equal to c, where c is some constant. Now we can rewrite this as y integral dx minus 2 integral y log y dy minus integral y dy is equal to c. Now, let us look at this integral of y log y. This is in the product form where one term is y, is algebraic, and the second term is logarithmic. So we'll have to use the product rule uv. But we cannot use this product rule uv equals to uv1 minus u dash v2 plus u double dash v3, where the dash represents the derivative and the suffix 1, 2, 3 represents the integration. Because for this particular uv rule, the function v has to be integrable, and if you see, v is equal to log of y, and log of y cannot be directly integrated. So we cannot use this particular uv rule. So we'll have to use integral uv dx is u integral v dx minus integral into bracket d by dx of u into integral of v dx into dx. So we'll have to first take the derivative of u, then we'll have to integrate v, and take the integral of the product. So this would be integral of y log y. Now this also, here the Liat rule is applicable, L-I-A-T-E. So log would be first, followed by algebra. So since multiplication is commutable, I can reverse the order, log y into y dy. So integral log y into y dy, where u is log y and v is y. Now this would be log y integral y dy minus d by dy of log y integral y dy into dy. So here log y is as it is, integral of y would be y square by 2 minus integral derivative of log y is 1 upon y, and integral of y is y square by 2. So here now y and y would cancel. So this would be, I rearrange this, y square log y by 2 minus integral of y by 2, as one y cancels out. So it's integral y by 2 dy. Now this would be y square log y by 2. Integral of y again is y square by 2. So it would be y square by 2 into 2. So integral of log y into y dy is y square log by 2, y square log y by 2 minus y square by 4. And let us call this equation number 4. So we can now substitute this 4 in equation 3. So now we have calculated this particular integral y log y dy. So y integral dx, integral of dx is x and integral of y dy is y square upon 2. So substituting equation 4 in equation 3, we get y into x minus 2 y square log y by 2 minus y square by 4 minus y square by 2, that is equal to c dash. So rearranging x, y and opening the bracket here, this would be minus 2y square log y by 2, and this would be minus 2 into minus y square by 4, which would be plus 2y square by 4 minus y square by 2 is equal to c dash. The 2 cancels and 2 cancels here with 4. So this would be y square by 2. So this would be xy minus y square log y plus y square by 2 minus y square by 2 is equal to c dash. So these two terms then cancel out each other. And we can write it as xy minus y square log y is equal to c dash. Now we can take the negative sign outside, minus y square log y minus xy. So We have reversed this y square log y minus xy by writing the negative sign outside, and that is equal to c dash. Multiplying both sides by minus 1, we get y square log y minus xy is equal to minus c dash. Now minus c dash can be written as another constant c. So this would be y square log y minus xy is equal to c, which is the required solution for the given differential equation. Thank you very much for listening.